A few months ago, I left an AI agent running overnight to handle a boring research task, and I woke up to a bill that made my stomach drop. Nothing dramatic had happened. The agent had not gone rogue or done anything scary. It had simply gotten stuck. It tried a step. The step did not quite work, so it tried again and again and again, all night long, each attempt costing a little money, thousands of times over. By morning, it had quietly spent far more than the task was ever worth, on a problem it was never going to solve. That was the night I learned the lesson I should have learned earlier. An agent that can act on its own needs a spending limit, the same way you would never hand someone a company card with no cap. So I built one. In the next 12 minutes, I want to show you exactly how I gave my agent a budget, why it matters, and the honest limits of the whole approach. First, why agents can run away. Let me explain why this happens. Because it is not a freak accident. It is built into what an agent actually is. A normal program does a fixed list of steps and then stops. An agent is different. It works in a loop. It looks at the situation, decides on the next action, takes it, looks at the result, and decides again, over and over, until it thinks the job is done. That loop is exactly what makes agents powerful, because they can adapt and keep going when a simple script would just give up. But it is also exactly what makes them dangerous to your wallet. The trouble is the part where it decides the job is done. If the agent gets confused, or the task is impossible, or it keeps misreading its own progress, that finish line never arrives. And so it just keeps looping forever, perfectly happy, with no idea that it is getting nowhere. A loop with no edge is the whole problem in one phrase. Left alone, it does not crash. It just keeps spending. Every step costs real money. Here is the part that makes the loop expensive, and it is worth understanding clearly. Every single time the agent thinks it costs money. These models charge by the amount of text they read and write, measured in little chunks called tokens. One step of the loop, reading the situation and deciding what to do, might be a fraction of a cent. That sounds harmless, and for one step it is. But an agent does not take one step. On a hard task, it might take dozens or hundreds, and a stuck one will take thousands without blinking. So the cost is not really per step. It is per step times however many steps it decides to take. And that second number is the one you do not control directly. The model decides how many times to loop, and each loop quietly adds to a meter that is always running. Once I understood that the agent was effectively holding a meter that only ticks up, and that nothing in the basic setup ever tells it to stop, the overnight bill suddenly made complete sense. So I started counting the spend. The fix starts with the most obvious thing, which somehow was not there by default. I started counting. Every time the agent takes a step, my code now records how many tokens that step used and what those tokens cost, and adds it to a running total for this task. So at any moment, I know exactly how much this particular job has spent so far. That sounds almost too simple to matter, but it is the foundation for everything else, because you cannot limit a number you are not even measuring. Before this, the spending was completely invisible until the bill arrived at the end of the month, which is the worst possible time to find out. Now the cost is a live number that goes up in real time as the agent works, right in front of me. Just being able to see it changed how I thought about the whole thing. A runaway loop stops being a mystery you discover later and becomes a number you can watch climbing. And once you can watch it, you can do something about it. Then I gave it a hard ceiling. I should say why I think this counting belongs in my own code and not in the agent itself, because it is a real choice. The obvious lazy option is to just tell the model, in its instructions, please keep an eye on how much you are spending and stop when it gets too high. And that does not work, for a reason that is worth understanding. The model is the thing that gets confused and loops in the first place. Asking the confused thing to also be the responsible adult watching its own spending is exactly backwards. When it is stuck, and a polite instruction buried in its prompt is the first thing to get ignored. So the meter and the limit have to live somewhere the agent cannot reach and cannot override, which means plain code outside the loop that the model has no say over. This is a pattern you see again and again in safe automation. You never trust the thing being limited to limit itself. You put the brake somewhere it cannot get to, so that no matter how badly it misbehaves, the brake still works. With a running total in hand, the actual budget is easy. Before a task starts, I set a number. This job is allowed to spend, say, 50 cents and not a penny more. Then, at the top of every single loop, before the agent is allowed to take its next step, my code does one quick check. Has this task already spent its budget? If the answer is no, fine, carry on, take the next step. If the answer is yes, the loop does not run again. That is the entire mechanism. A cap checked at the start of every turn that the agent cannot talk its way past because it is not the agent making the decision. The check lives in my code, outside the model, where the agent has no influence over it at all. This is the same idea behind any good safety limit. The thing being limited does not get a vote. The agent can want to keep going as badly as it likes, but if the budget is spent, the loop is simply over, and there is nothing it can do about that. What happens when it hits the cap? So what does hitting the limit actually look like? The agent does not crash, and it does not silently keep going, which is the important part. It stops cleanly and it tells me. It says, in effect, I have spent my budget for this task and I am not finished. Here is how far I got and here is what I was about to try next. Then it waits for me. And now I get to make the call that the agent could not make for itself. Maybe it was genuinely close to done and I give it a little more room to finish. Maybe it was hopelessly stuck and I kill the task, having lost 50 cents instead of $50. Either way, I find out in the moment, while it is cheap to fix, instead of the next morning when the damage is already done, that handback, the agent stopping to ask a human when it hits a wall, is the single most valuable behavior in the whole setup. A tool that stops and asks beats a tool that confidently spends your money into the ground. A gentle warning before the wall. I added one more thing, because a hard stop on its own felt a little blunt. Before the agent hits the full budget, when it crosses something like 80% of the cap, it sends me a quiet heads up. Just a note that says this task is getting expensive and is approaching its limit. That early warning means I am not always finding out at the very last second. Sometimes I see the warning, glance at what the agent is doing, and realize it is on a sensible path that just needs a bigger budget for this particular job. So I raise the cap before it ever stops. Other times, the warning is the first sign that something has gone wrong, and I step in early. It is a small touch, but it turns the budget from a single hard wall into something more like a speedometer with a warning light. The wall is still there as the real safety net, but most of the time the warning light is enough to keep me in control before the wall ever matters. Let me be honest about the limits. Now the honest part, because a budget is a blunt instrument, not a clever one. It does not know whether the money was well spent. It cannot tell the difference between an agent making real progress and an agent spinning its wheels. It only knows the total, and it stops when the total is too high. Full stop. That means it will sometimes cut off a task that was genuinely about to succeed just because it ran a little over, and that is annoying. It also will not save you from an agent that does something wrong but cheap, like deleting the right number of dollars worth of the wrong thing. The budget guards your wallet, and only your wallet. It is not a substitute for the other safety checks, like reviewing what the agent is allowed to touch in the first place. I think of it as one specific seatbelt, not the whole car. It catches the one failure that bit me, the runaway cost, and it catches it reliably, but it is not pretending to be more than that. What it costs and what stays mine. The cost of building this was almost nothing, which is the best part. It is a counter and a single check at the top of the loop, an afternoon of work, and it has already paid for itself many times over in bills that never happened. Running it costs nothing extra because counting tokens is just bookkeeping the agent was generating anyway. And what stays my job is the one decision that actually requires judgment, which is the number itself. How much is this task worth? A quick research job might be worth 20 cents. A big important one might be worth $10. Only I can decide what a given task deserves to cost, because only I know what it is for. The agent handles the work, the counter handles the watching, the cap handles the stopping. But setting the value of the task, that stays with me, and honestly it should. That is exactly the kind of decision you never want to hand to the thing doing the spending. A quick word on the failure that started it. I keep coming back to that first overnight bill, because it taught me something beyond just spending. The scary part was not the money. In the end, it was how silent the whole thing was. There was no error, no crash, no warning light. By every technical measure, the agent was working perfectly. It was taking steps, making requests, getting responses, doing exactly what an agent does. It just happened to be doing all of that in a tight little circle that went nowhere. And nothing in the system thought that was a problem, because nothing in the system was even looking. That is the real lesson. The dangerous failures in automation are rarely the loud ones that crash and stop. They are the quiet ones that look like success while they burn through your money or your time. A budget is one way of forcing one of those quiet failures to become loud. By giving it a hard edge, it will eventually hit. And once I started thinking that way, I went looking for other silent runaways in my setup and found a couple. That mindset, make the quiet failures loud, turned out to be worth more than the budget itself. So should you build this too? Would I tell you to do this? If you are running agents that can act on their own and spend real money doing it, then yes, without hesitation, before you do anything else fancy, it is the cheapest insurance you will ever write. If you are only ever chatting with an AI by hand, you do not need it because you are the loop, and you will simply stop when you have had enough. But the moment you hand the loop to the machine, you have to give it an edge because it will not find one on its own. One overnight bill taught me that. And a counter, a cap, and a warning made sure it only had to teach me once. I am going to keep sharing the unglamorous practical side of running AI for real, the guardrails nobody puts in the demos. If that is your kind of thing, subscribe and follow along, because there is a lot more coming. Thanks for watching, and I will see you in the next one.